On May 5, 1956, a Southern Pacific freight train was racing across the Arizona desert when something failed beneath the 13th car. Within seconds, 34 freight cars were off the rails. Some collapsed beside the track, others piled into one another. Steel, wheels, cargo, and broken equipment blocked a main line carrying traffic between Arizona and California. The railroad could not simply drive around the wreck. It had to make the wreck disappear. From Tucson came one of the strangest machines ever built for a railroad. A steam-powered wrecking crane capable of lifting 120 tons. Railroaders called it the Big Hook. Its boom rose above the wreck. Steel cables tightened. Cars weighing tens of tons were lifted, swung aside, or placed back onto repaired track. According to the surviving Southern Pacific record, the line was probably reopened within 24 hours. This was what wrecking cranes were built for. So how did railroads create machines powerful enough to pick up their own locomotives? And why did nearly every major American railroad once keep giant cranes waiting for the moment everything went wrong? Railroads were extraordinarily efficient as long as everything stayed on the rails. The problem began the moment something did not. A freight car leaving the track could tear up ties and rails. A locomotive could roll onto its side beside the right-of-way. A major derailment might scatter cars across both tracks, destroy switches, damage bridges, or pile wreckage inside a narrow cut. And unlike a truck on a highway, a train could not simply steer around the obstruction. One wreck could close the only route through an entire region. That made cleanup a race against time. Behind the blocked line, freight trains accumulated. Passenger trains stopped. Mail was delayed. Livestock, coal, food, machinery, and industrial materials all waited for the same few hundred feet of railroad to reopen. In regions where railroads were the dominant form of transportation, the consequences were even larger. Southern Pacific records describe its Arizona routes as vital links for mining, agriculture, passenger movement, military activity, and transcontinental commerce. A prolonged interruption could become enormously expensive. The railroad therefore faced a mechanical problem that existed almost nowhere else. It had built locomotives powerful enough to pull thousands of tons. Now it needed another machine powerful enough to pick those locomotives up when they fell over. Railroads had been dealing with derailments long before giant steam cranes existed. In the early years, locomotives and cars were smaller. Crews relied on jacks, timber blocking, chains, ropes, tackle, hand-powered derricks, and enormous amounts of physical labor. If a wheel had merely dropped beside the rail, workers might jack up the car, construct a temporary ramp, and pull it back into position. But serious wrecks were different. A locomotive lying on its side represented an enormous dead weight, with almost no convenient way to move it. Worse, crews often had to work from the railroad itself because the wreck might be miles from the nearest road. As locomotives became heavier, manual recovery became increasingly impractical. Railroads began placing cranes directly on railroad cars, so the lifting machine could travel wherever the tracks went. Wrecking cranes of various forms were already part of American railroading before the Civil War, but their size increased dramatically as the equipment they were expected to recover grew heavier. The logic was unavoidable. Bigger trains created bigger wrecks, and bigger wrecks required a much bigger hook. By the 1890s, specialized manufacturers were turning the railroad wrecking crane into a serious piece of heavy machinery. Industrial Works of Bay City, Michigan, began building cranes in 1893. Its early machines were relatively modest, but locomotive weights were increasing so quickly that crane capacity followed almost immediately. Within 11 years, Industrial Works had gone from building a 12-ton crane to machines capable of lifting 100 tons. Soon came 150-ton designs, followed by 200-ton giants. The Delaware and Hudson provides a clear example of the arms race. It purchased 100-ton steam wrecking cranes in 1904 and 1907. But by the early 1920s, those machines were already becoming inadequate for newer locomotives and high-capacity cars. In 1921, the railroad bought a 160-ton crane specifically to reduce the delay caused by major wrecks. Its own historical record explained that 100 tons was no longer enough to handle modern equipment quickly. Other railroads followed the same path. Southern Pacific eventually maintained roughly 20 wrecking crane and tool car combinations across its 9-state system, with lifting capacities ranging from about 100 to 250 tons. The wrecking crane was no longer an emergency accessory. It had become essential railroad infrastructure. A railroad wrecking crane looked like a locomotive had been crossed with an industrial lifting machine. The entire crane sat on a heavy rail chassis. Above it was a rotating body containing the power plant, machinery, counterweight, winding drums, and controls. A massive steel boom extended from the front, carrying one or more hooks suspended by steel cable. On steam-powered models, a boiler supplied pressure to small steam engines inside the crane. Those engines powered the hoisting machinery, raised and lowered the boom, and rotated the upper structure. But lifting a locomotive created a dangerous problem. The farther the hook moved away from the center of the crane, the greater the leverage trying to overturn the entire machine. That was why wrecking cranes carried enormous counterweights and extendable outriggers. Consider Southern Pacific's 120-ton crane built in 1910. The machine itself weighed more than 217,000 pounds. Its boom could extend nearly 40 feet. 3 outriggers on each side could spread the crane's support base by more than 23 additional feet. Fully prepared, the machine became less like a railroad car and more like a temporary steel foundation built around the track. Capacity also changed with distance. Nevada Northern's 100-ton wrecking crane could lift its full rated load at a radius of about 17 feet, but only around 80 tons at 23 feet. The farther the load moved from the crane, the less weight it could safely lift. This meant wreck recovery was not simply about attaching a hook and pulling. The crane had to be positioned correctly. The outriggers had to be blocked. The load had to be rigged. And every lift had to keep hundreds of thousands of pounds of steel in balance. The big hook rarely traveled alone. Behind it came a specialized wreck train, carrying nearly everything a crew might need to rebuild a railroad in the middle of nowhere. A tool car carried chains, cables, blocks, jacks, rigging equipment, replacement parts, and heavy tools. The car, paired with Southern Pacific's Tucson crane, eventually contained 11 specialized steel compartments dedicated to wreck service. The National Register documentation notes that the crane and tool car effectively functioned as one unit. Neither was truly useful without the other. The train might also include an idler car, supporting or providing clearance for the long boom during travel. For major assignments, additional cars followed. Bunk cars gave the wreck crew somewhere to sleep. Supply cars carried materials. Track equipment arrived for rebuilding damaged rails and ties. Locomotives provided transportation and switching power. A major wreck could keep crews on location for many hours or several days. So the railroad did not simply dispatch a crane, it dispatched a mobile repair base. The wreck train carried the machine that lifted the wreck, the tools that dismantled it, the workers who repaired the railroad, and sometimes even the beds where those workers slept. Southern Pacific routinely sent bunk or dormitory cars when crews faced lengthy work in remote locations. It was an emergency railroad designed to rescue the real railroad. No two derailments looked exactly alike. A freight car might sit upright with one truck off the rails. Another could lie completely on its side. A locomotive might be buried in dirt below an embankment or trapped beneath other wrecked equipment. The first job was therefore not lifting. It was creating a safe place from which lifting could happen. Crews cleared debris, inspected the track, positioned the crane as close as possible, and built heavy timber supports beneath the outriggers. The crane needed stable ground because a heavy lift could transfer enormous force into a very small area. Then came the rigging. Chains, cables, hooks, and slings were attached to structural points capable of carrying the load. The crane operator slowly took up the slack until the rigging became tight. Then the weight transferred. A locomotive that had seemed permanently fixed to the ground began to move. Sometimes the goal was simply to lift one end high enough for workers to repair or reposition the wheels beneath it. In other situations, the crane could raise an entire section, rotate the load toward the railroad, and lower it onto repaired track. The movement had to be controlled carefully. Lift too quickly and the load could swing. Move too far from the crane and lifting capacity dropped. Place the outriggers poorly and the crane itself could become the next piece of equipment requiring rescue. For the largest wrecks, railroads could bring in a second big hook. Southern Pacific sometimes dispatched cranes from neighboring divisions so two crews could work from opposite ends of the wreck and clear the line faster. The objective was not to make the wrecked equipment beautiful again. It was to get it out of the way and give the railroad its track back. Wrecking crane crews occupied one of the strangest jobs on the railroad. Most days, nothing happened. Then the call came. A train was off the rails somewhere down the division, and the wreck crew had to leave immediately. They could arrive at night, during a storm, in desert heat, or on a frozen mountainside. The site might contain twisted rails, unstable cars, leaking cargo, broken timber, and heavy equipment resting at unnatural angles. The crane operator controlled the lift, but dozens of other decisions happened below the boom. Workers positioned blocking beneath the outriggers. Rigging crews attached chains and cables. Carmen inspected damaged rolling stock. Track crews rebuilt the roadbed. Locomotive crews moved wrecked cars once they could roll again. Communication mattered because the crane operator could not always see every worker around the load, and everything was heavy. The hook was heavy. The rigging was heavy. The timbers were heavy. The object hanging above the crew could weigh dozens or even hundreds of tons. The big hook supplied extraordinary force, but the machine could not decide where to apply it. That judgment belonged to the wreckmaster and the crew working beneath the boom. The history of the wrecking crane followed the same pattern as the history of the locomotive. Every time trains became larger, recovery equipment had to grow with them. Industrial works began with a 12-ton crane in the 1890s. By 1904, it was producing 100-ton machines. Roughly a decade later, 150-ton cranes were appearing, and by the early 1920s, capacities had reached 200 tons. The reason was simple. A crane designed to recover 19th-century rolling stock could not necessarily handle the locomotives of the next generation. That forced railroads into an expensive cycle. A wrecking crane might spend most of its life waiting in a yard, yet when disaster came, it had to be powerful enough to lift the heaviest equipment the railroad owned. Southern Pacific positioned crane and tool car sets at major yards across its network. Their capacity eventually ranged from 100 to 250 tons. They were machines built for rare events, but rare events with enormous consequences. A railroad could spend years maintaining a crane that barely moved. Then, one derailment could justify the entire investment. Because every hour the main line remained blocked cost money, and the big hook existed to buy those hours back. The 1956 derailment near Stanwix, Arizona, showed exactly why these machines survived for so long. Southern Pacific Freight Extra 6208 West consisted of 3 diesel locomotives, 95 cars, and a caboose. As the train crossed a siding switch at approximately 53 miles per hour, a truck side frame failed beneath the 13th car. That car derailed. Then, the 33 cars behind it followed. The result was a massive wreck scattered across a single-track transcontinental main line, roughly 164 miles west of Tucson. Southern Pacific had only one wrecking crane assigned to the Tucson division. It was dispatched with its tool car. The surviving historical record credits the crane with allowing this vital route to reopen with minimal disruption, probably within about 24 hours of the derailment. Think about what that meant. 34 freight cars had left the track, rails had been damaged, cars were piled across the right-of-way, and within roughly a day, trains could move again. That was the real measure of a wrecking crane, not how high it could lift, not how impressive it looked, but how quickly it could turn a railroad disaster back into a railroad. By the second half of the 20th century, the railroad wrecking crane began losing the job it had dominated for generations. Steam was the first thing to go. Maintaining boilers, pipes, valves, and specialized steam machinery became increasingly expensive. Some wrecking cranes were converted or replaced by diesel-powered equipment. But the larger change happened outside the railroad. Highways improved. Powerful truck-mounted cranes became widely available. Bulldozers, excavators, hydraulic cranes, and other construction equipment could reach wreck sites from nearby roads. Railroads no longer needed to own a giant, specialized crane that might sit idle for months. Southern Pacific's Tucson wrecking crane remained in service until 1989. When it was retired, clearing major wrecks on the division was turned over to private contractors using non-rail heavy equipment. The railroad had once needed its own mechanical rescue army. Now, it could call one from outside. The big hook had become obsolete. Today, most railroad wrecking cranes sit in museums and preservation yards. Their hooks hang motionless. The outriggers are folded in. The wreck trains they once led have disappeared. But a few survivors still show what these machines represented. Nevada Northern's 100-ton steam crane, built in 1907, was restored to operation nearly a century later. Southern Pacific's 1910 crane survives with its tool car in Arizona. They belonged to an era when railroads had to carry their own solution to catastrophe. The big hook was not built to make trains move. It was built for the moment after everything stopped. And for nearly a century, whenever thousands of tons of American railroad ended up where it was never supposed to be, these giant cranes came down the line to put it back.